Hi again. My name is Imanali, and I'm gonna present you about the second video of polymorphism video series. So basically, in the previous slides, I have explained the concept of polymorphism, and I have given you the definitions from the simple definition to the more technical definitions about polymorphism. And in the previous uh, video, I have explained polymorphism from the real-time examples, and then I have given you some of the coding examples as well in the slides. But in this example, in this video, I'm going to show you actually that how actually the polymorphism will going to be implemented, and from the coding perspective, how we can code the concept of polymorphism in Visual Studio 2013. So for the demonstration purposes, I have already created the classes, and these two examples are being presented in the previous demonstration of the slides. So one example was related to the classic shape example, and the other one is the specific example for social networks. So let me give you an overview of these classes which I have created. So as I have explained in the previous video, that the base class will gonna need to be the abstract class. And what it means, that we cannot instantiate an abstract class, right? So the purpose of this base class is that for the polymorphism, specifically in this project, so we're gonna use, so I am going to use this base class only I'm going to use this shape class only as a base class. So all other classes are going to be inherited from this shape class. So I have declared this class, and I have given some of the properties. Those are common in all the shapes. So whenever any class that will derive for this from this shape class, we're going to inherit down these properties, right? And there is a method called draw, which is actually a virtual method, and the purpose of this virtual keyword is that we are going to override this draw method in all the derived classes. So because this is a base class, so we have given a virtual method. We have given a virtual keyword with the draw method over here. So now let's take a look at the derived classes. So basically these are pretty much straightforward classes. The circle inherits from shape, and rectangle inherits from shape as well, and triangle inherits from shape as well. So this colon sign represents the syntax, inheritance syntax in C#. So I have given the draw method a virtual. I have declared a draw method as a virtual in the base class, but in the circle class, which is actually a derived class version of the shape, I have given this draw method a keyword override. So what it means, that as I have explained in my previous lecture, that these two keywords, virtual and override, these are the heart and soul of polymorphism, of implementation of polymorphism in C#, right? So I have overwritten this draw method, and as you can see, the definition of the draw method in the base class, the message which is going to print on the console is different, and the message which is going to print on console for the derived classes are different. So in this case, if we are drawing a circle, we are drawing a rectangle or a triangle, the message will gonna be the same. The message will gonna be different. So now, well, in the actual example, this is just for the demonstration purpose, but in the actual example, these two lines of code will gonna be replaced with the actual drawing. So if you want to use the circle or the shape implementation, you can use the graphic library of .NET, which .NET provides, and you can make leverage of those built-in classes of .NET framework classes, and you can use those methods to actually draw these shapes. Like you can call the methods in the .NET framework graphic library to draw a circle, to draw a rectangle, and so on. Right. So, but just for the demonstration purpose, I have represented the definition of draw method in the drive classes by these console.writeLine statement, which will actually print these messages, these strings on the console. So now let's go ahead and let's write some of the code. So I'm going to present you the simplest way to represent the polymorphism or the polymorphic behavior in the C# applications. So first I will declare a shape object, right? So this is over here the declaration. I am declaring the shape object of base class shape, and then I am going to give it a reference. I'm going to instantiate a drive class, which is a circle in this case. So what will going to happen, that an instance of circle class will gonna be created in the memory, and its reference will going to be set in the shape object variable, right? So as the classic definition says, in inheritance, every instance of drive class is actually an instance of base class, right? So over here that definition is becoming true, that I have declared a base class instance, which is shape object, and I have given a reference to the drive class. So now what I am going to do, I will call shape object dot draw method. So now in these two statements, actually the polymorphism is completed, right? There are only two steps. First is to declare the base class variable, and then assign the reference of the drive class, and then call the method. So in this case, the draw method, when the program starts executing and control comes on this line 101, so what will happen, it will lately bind or dynamically bind this draw method of circle class, and it will call this method, right? So this message, drawing a circle, we're going to be printed on the console. So now what I'm going to do, I'm going to use the existing, because I have declared this shape object only once. This is when I declare it, so during the compile time, the compiler will know that this shape object belongs to the shape class, right? And as I have described in previous demonstration of the slides in previous video, that the runtime type of an object is different from the compile time type, right? So now I'm use the same object, which is shape object, and I'm going to assign it a new reference of rectangle class, right? And then I'm going to call shape object dot draw method. So in this case, the draw method of rectangle, which is a drive class, will going to be called, and then I'm going to again assign shape object to a new triangle, and shape object dot draw. So this is a complete example of the implementation of polymorphism, and at this point the polymorphism is being implemented, because what is happening, we are and what is happening over here, that we are only calling one method of draw. We are only calling one method of draw for each for the base class object, but we are just changing the reference to the child classes, right? So that's how polymorphism is achieved in C sharp. So now let's just build this program. I'm gonna build it. Okay, and now I'm going to run this program. Okay, so now as you can see, what happened that the first because just observe the order of the instances, that first we created a circle instance and then we call the draw method. So drawing a circle is basically a message in the draw method of circle class, so it calls first. The second message is performing base class drawing task or operations. Basically this message is called because we have called the base.draw method, right? So what it is doing right now, it's basically dynamically calling the circle class draw method, and in the circle class draw method we are calling the base class draw method. So base class draw method is the method of shape class, and this method is printed over the console, right? Now in the order, the next message should be the rectangle. As you can see, drawing a rectangle, performing base class drawing task, and then the third message is triangle. Okay, so that's perfect. Polymorphism has been implemented and I have demonstrated that. But the thing is, there are a lot of many ways to implement polymorphism. So the way I have demonstrated over here is just a very simplest and beginner level implementation of polymorphism. We are just creating one object and then assigning the a reference to the base class variable and then calling the draw method, right? So this is just a simplest form of the implementation of polymorphism. So there are so many other ways through which you can implement the polymorphism, right? And there are also other types of polymorphism which I'm gonna describe in later videos. But over here I'm just going to give you an idea that how from another way the polymorphism can be achieved, and which is I'm going to create a list of shape. So basically I am going to create a list of base class shape, and I'm going to call that list as a shapes, and then new list of shapes, and I'm going to initialize this list with the objects. So over here what I'm going to do, I'm gonna instantiate new circle. Okay, I will keep the order same, but if I will declare the objects in the same order, then the message prints on the console will gonna be the same as this is in this example. But for the demonstration purpose, what I'm going to do, I'm going to change the order. So first circle, and then I'm going to create a object of triangle, and then object of rectangle. Okay, so this declaration over here, these three statements 1, 2 and 3, these are sum up into this one statement, right? Of course the order is different. And now what I'm going to do, I'm going to call a for each statement or a loop on each shape, which is let's call it a shape in shapes, and then I'm gonna call shape.draw method, right? So for this is a one way of implementation. I'm gonna one way of polymorphism implementation, and this is second and simplest way so this is the second way of implementation. So now I'm going to run this program, and there will be 6 messages going to print out on the console, but I'm going to break this program, right line, just with this bunch of characters. Okay, so now let's run this program, and when it will run, so now you can see in the first implementation, first the circle message has been printed because the first object is circle, then triangle message because the second object is triangle, and third the rectangle message. So polymorphism is in action in these implementations, but in the second set of messages, you can observe that first is circle, and then the rectangle, and then the triangle. So this is the simplest way to demonstrate how polymorphism is working. It's basically dynamically calling the derived class implementation of draw method, and based on the object reference that is being set to the the derived reference is being set to the base class reference. Okay, so this is this coding example is related to the shape, which was the first example I have shown in the previous video slides. Now let's take a look at the second set of examples. This is a more general and more specific, not general but more specific example about social networks. So what is happening over here, I have declared a social network class, which is again an abstract class, and this is a base class, and I have provided an implementation of getData method, which is actually returning a list of strings. So in real time, the purpose which I have explained earlier, that the purpose of this class model is to implement the APIs from different social networks. So Facebook provide its own APIs for getting the data or the feed that is happening on that is being posted on Facebook. You can get that feed with certain API methods. Twitter has its own API methods, and similarly other networks have their own API methods. So you can, in real time, you can replace this piece of code with the implementation of calling the API methods and representing the real time list of messages basically. So in this demonstration I just wanted to keep it simple. So in the give data of the base class version is returning a list of string, and I'm just returning this one, but in Facebook I have overwritten this method, and it is returning a list which consists of two messages. So let's change the code over here, and social network is basically the base class. So what I'm gonna do, I'm gonna change social network over here, and then I'm going to change the name networks. It's a good programming practice that keep the meaningful names to the variables or the list or arrays, so it will be easy to understand for the other programmers, those are using our program. And similarly I need to change the derived classes, the derived class name over here. So first is Facebook, and second is Twitter, and let's remove the last one. Okay, so we also need to, I am going to demonstrate with this implementation, so let's change over here. Similarly the variable name, network, and over here it should be the social networks. And now because the implementation is a bit different, in this case social network, the getData method is actually returning a list of strings. So we need to declare a list of string, and let's call it a messages, and let's just declare it. And over here, when this method will be called, it will return a list of strings, and that list of string will be assigned to messages list. So so basically this is not draw, this is get data. Okay, so now we also want to print those messages, so let's write another loop and string message in messages, and now let's write console dot write line message. Okay, let me delete this piece of code. So this is the implementation of polymorphism. In this loop, we are calling the get data method for each of network, and because this list of base class pointers, but we are actually calling the drive class implementation. So let's run the code. Okay, so as you can see, this is the first message, hello, this is a message from Facebook, and hello, this is another message from Facebook, which is being called because the Facebook is the first object in the list, and then the second object is Twitter, so we are getting the Twitter messages. And as you can see, this is a get data implementation of Twitter, so these messages are on second display, and these messages are on first display. And in the previous implementation, I was calling the base class implementation, but base class version of get data, but in this implementation I am not calling it, just to be make you understand the difference, that how we can use the polymorphism. So I guess yeah, so that's it. These are the coding examples which are related to the previous video, and in the later videos, the series of object-oriented programming videos, I'm going to demonstrate the advanced concepts of polymorphism, and those are basically the different types of polymorphism, how we can achieve that in C#, and those are interface polymorphism and inheritance polymorphism and polymorphism by abstract classes. So in actually this is an implementation of polymorphism through abstract classes because I have declared this as abstract. So but later on I will give you the details. Thank you very much and have a nice day.